Hi guys, Mr. Rella here, and this is a lecture for Chapter 6.2, Describing Chemical Reactions. You will need your Chapter 6 classwork packet. This is for my 8th graders in periods 4 and 5. If you're in 7th grade, please close the video and go to Chapter 10.2. That one's for you. Alright, in the packet, make sure that you already did Chapter 6.2 key terms. Again, got to put a drawing in the box with at least 4 colors. Look up the definition in the back of your textbook. If it says page number, I forgot to mention it, leave it blank. Don't put any page numbers there because we'll figure it out where it goes in what order when we come back to school and put it in our science notebook. Because remember, we didn't finish Chapter 5. So we have to finish up Chapter 5 and then stick Chapter 6 in there. All right, the page that you need to work on is Chapter 6.2, Describing Chemical Reactions. Notice that the page is blank. This I got from my website. Now, you can always pause the video and copy it from here, but it might not be that clear. It might come out blurry if I move the camera too much. So I recommend going to my website and downloading it. Now, what's the point of this lecture online? It's because notice that this part's still blank. The notes I'm going to give you, it's going to help you put extra information here and to put a summary on the bottom. So let's begin. Chapter 6.2, the EQ. How do chemical symbols help scientists communicate better? So the idea is, instead of writing out the word oxygen or carbon, scientists have symbols. So for example, like right here, Ca is calcium, C is carbon, O is oxygen. Instead of writing it out, it's a lot easier to symbolize it. For example, whenever you text a friend, if you write LOL, it's a lot easier than writing to your friend that you're laughing out loud. I mean, that sounds kind of silly. LOL is a lot better. You're conveying the same message even though you're saving time and space. Why would you want to save space? Well, there was a time where Twitter, you could only write 140 characters. So if you were on Twitter, you were very, very limited as to how much you could write. So people started abbreviating everything and anything they could to try to fit as much of a message into short space. Well, scientists have the same concept. Instead of writing out the word calcium or carbon or oxygen, by putting symbols, you convey the same idea. It's a lot faster to write it. You save time, you save space. If I would have written out calcium, carbon, and oxygen, I would have ran out of room on this whiteboard right here. Okay, so here is the way an equation looks like. I believe we talked about it last time. Your reactants, think of it as like your ingredients when you're baking a cake. So if you have like, milk, flour, butter, whatever you need to bake a cake, these are your ingredients. Now, when you put it in the oven, you have a chemical reaction. Now, this arrow, what we say is yields. We're going to say equal to. In math, it might be like, 2 plus 3 equals 5. But here, it's this chemical will yield this product. Your product is what you produce, what you made. So, for example, here we have CaCO3. Now, we have a chemical reaction going on, and notice that these got rearranged. Now, more on that later. This is not entirely new. I mean, we still have calcium here. We have it here. We have a carbon here. We have 1 carbon. And here we have 3 oxygens. And check this out. 1 oxygen here plus 2. That's 3. So we have what's called a conservation of mass. We'll get more on that later. But what we're going to learn is in chemistry, chemicals, when they start off in the beginning, they just simply get rearranged into something else. It's not magic. We didn't really create a new chemical. We actually just rearranged the existing atoms into a different order. Now, this is the difference between a symbol and a formula. Symbols would be like a single element, like Ca is calcium, C is carbon, O is oxygen. CaO is calcium oxide. You do not find this on the periodic table. You'll find calcium in the periodic table, and you'll find oxygen on the periodic table. But calcium oxide is when these elements come together to form a chemical. So we call this a formula. Carbon dioxide, the stuff you breathe out, is 1 carbon and 2 oxygen. Right here, sodium azide, NaN3, 1 sodium, 3 nitrogen. Notice that it's a combination, it's a compound, it's made up of different elements coming together. Okay, next page. Look at that, we're already halfway there. The conservation of matter. If you want to read up more about it, it's on page 226 and 227 of your book. It's basically a law that was developed by this French chemist, Antoine Lavoisier. He pretty much said that nothing could be created or destroyed. We could just be rearranged. For instance, if you have this wood right here, and you burn it. Let's say that you measured it and it was 2 kilograms, 2,000 grams of wood. Okay? Now, when you burn it, obviously you get ash. But maybe you've noticed whenever you burn a campfire or wood in your fireplace is that the amount of ash produced is way lighter than the actual wood. Well, what Lavoisier said is that, well, we had what's called an open system. When this wood was burning, a lot of the stuff escaped into the atmosphere, you know, like the smoke and the soot and other particles. He said, well, what if you were to trap this into a room or a structure or a box or something where when the wood burned, everything that was made from the burning wood was trapped in a closed container. He called it a closed system. According to his hypothesis, if you burn 2,000 grams of wood, you will end up with 2,000 grams of something else. And sure enough, when they've done similar experiments like this, it's been shown that he was correct. The reason why you had a lot less ash, you had 500 grams of ash, for example, and the wood weighed 4 times more, is because he predicted a lot of the stuff got into the air, even smoke. And smoke might be very lightweight, but it still carries mass. Well, if you add up all the stuff that burned from the wood and you trapped it, you would get, this is just made up numbers, but it's just to prove a point. You would get like 500 grams of ash and maybe 500 grams of soot. If you don't know what soot is, if you look inside a fireplace and it's like that black gunk that's inside the walls of the fireplace, it's very sticky, that's soot. And 1,000 grams of smoke. Now, if you do the math, 500 plus 500 plus 1,000 is your 2,000 grams. So basically what happened is that 2,000 grams of wood, when it went through this chemical reaction of burning, it turned into 2,000 grams of something else. So his hypothesis was, and it became a law, that in chemistry, we don't really create or destroy atoms or chemicals. We just simply rearrange the atoms into a different order. Now, there are 3 types of chemical reactions. It depends on what's happening. Okay? If you look at, for example, synthesis right here, synthesis is when you basically combine 2 elements to make up a compound. So, for instance, you're combining here 2 different things to make one. So I visualized it. Here's the key, and this will count as a Cornell note. So I drew this red triangle as hydrogen, this green trapezoid is oxygen, this purple box is chlorine, this vertical rectangle, yellow, is sulfur, and this horizontal rectangle is iron, Fe, the blue one. So if I have here 2H2, well, H is a triangle, so I drew 2 triangles. That's H2. And the reason why I put 2 H2 is because there's 1, there's 2. So this is H2, that's H2, it's 2 H2s. Now look at O2, oxygen, I put 2 oxygen together. Notice that all 3 of these come together to form 2, and these are water molecules, 2H2O. The triangles were the H's, H and H, H2, and then O. So 3 individual compounds make 2. Synthesize, they combine, 2 different things combine. Now, the opposite is decomposition. Like when something decomposes, it breaks down. If, you leave an apple on the ground, it starts rotting, starts decomposing, it's broken down. What happens is a more complex compound breaks down. Like this one came together to form something bigger. This was made up of 2 pieces, 2, and this is made up of 3. So it got bigger. But notice this one breaks down. This one, H2O2, that's hydrogen peroxide. It's the stuff you can use to bleach your hair. Or if you ever use mouthwash that fizzles in your mouth, it's peroxide. This is H2O2, 2 hydrogen and 2 oxygen. That's what it looks like. There's a hydrogen at the end, oxygen's in the middle, and hydrogen right here. And we have 2 of them, 1, 2. Now, if you ever notice, hydrogen peroxide bottles are actually dark bottles because hydrogen peroxide, if you leave it out in the sun, it breaks down into water and oxygen. And basically you've ruined it. So, when you buy rubbing alcohol will be in a clear bottle, but peroxide will be usually like a dark brown or black bottle. Well, this is why. Peroxide is known to break down. And what happens is this is made up of 4 parts. 1, 2, 3, 4. Notice that water is 3 parts. 2 hydrogen, 1 O, 1, 2, 3. And this one, 1, 2, 3. And then O2. This is stuff we breathe, the 1, 2. So see how we went from a bigger molecule to a smaller one? That's decomposition. Finally, the last one is replacement, and that's exactly what the word means. You're replacing it. You're switching one for the other. So right here we have FeS, iron sulfide. This is iron, Fe, see, Fe, and then sulfur, iron sulfide. And we have hydrogen with chlorine. Okay. Now hydrogen is a triangle right here, and then the purple one is chlorine, and we have two HCl, so that's HCl, there's two of them. Now, when they come together, notice that it's kind of like we swapped the yellow one for the purple one. The purple one goes here with the blue one, and the yellow one goes, it's like they traded places. They replaced each other, so it didn't really break down, and it didn't really get bigger. They just traded places. Now, when chemicals do that, and for this example, you're just trading places. It's called replacement. Now, one thing I do want to show you really quick, I forgot to mention this in the closed system. Let's go back to this part right here. Remember this right here? I kind of wrote it down to show you how Antoine Lavoisier's idea works. Here we have calcium and carbon and 3 oxygen. See? 1 calcium, 1 carbon, 3 oxygen, and then they get rearranged. Now, how many calciums do we have here? Well, it's only 1. Oxygen, we have 1 here, and then 2 here, so 1 plus 2 is 3. So we have 3 oxygen, and for carbon, we just have 1. So notice that the numbers on the left match the numbers on the right. We started with 1 calcium, we end up with 1 calcium. We started with 1 carbon, end up with 1 carbon. Start off with 3 oxygen, 3 oxygen. Now down here, a little bit more complicated. There's only 1 carbon, right there's C, and there's 4 H's. Now here it gets tricky. We have O2, so that means there's 2 oxygen, but then we multiply that by 2, because there's 2 of these. So 2 times 2 is 4. So to visualize it, O2 looks like this, OO, and then we have another OO, so this is 1 O2, and here's another O2, so it's 4 O's total. Now, if we count for this equation, we count the number of carbons, there's only, out of this whole thing, there's only 1 carbon. If we look at hydrogen, there's H2 here, but there's 2 of everything in here, so 2 times 2 is 4. And when we look at oxygen, there's 2 oxygen here, and in here there's 1 oxygen, but 1 times 2 is 2, so there's 2 here and 2 here. Together that's 4. And if we look at it, these numbers here match these numbers here. It's the law of conservation of mass. We never destroyed any carbons, we never created carbons. We started with 1 carbon, end up with 1 carbon. Start with 4 hydrogen, end up with 4. Start with 4 oxygen, end up with 4. We just rearranged everything in different order. So that's basically this idea right here. We're just taking the wood and rearranging it into different chemicals. But we started off with 2,000 grams of an object of mass, and we end up with 2,000. We just rearranged. That's chemistry in a nutshell. Okay, guys, we only have 1 lecture left. It's going to be chapter 6.3. I'll upload it sometimes on Friday, and then you are done. I know they extended this shutdown for the entire month of April. This is the only packet you're getting. So when you come back, at the end on May 1st, I do expect this packet to be done and completed and turned in, and we'll do a test review, and we'll already test on chapter 6 soon after. If you have any questions, email me or reply to my remind post, okay? I'll see you guys in about 2 days. Bye.